I'm Ed Gaviria. I'm one of your science fellows. I'm a PhD in civil engineering, and one of the things that I work with is transportation, and I look at problems dealing with traffic congestion. But before we get into that, let me tell you a little bit about myself. I was born in New York City, and about a year later, my parents moved to Colombia, where I grew up. Some of the things that I really enjoy doing are spending time outdoors. One of my favorite trips of all time was going up to Machu Picchu and exploring the ruins there. Another of my favorite trips involved guiding a raft down the middle fork of the Salmon in Idaho. I love sports as well. I just don't have that much time for them right now, so I do a lot of sports that I can do by myself, like Ironman triathlons. That's where you swim 2.4 miles, bike 118, and then you run a full marathon. We look at ways to solve traffic congestion by promoting and encouraging people to walk more. Yeah, I know, walk more. Use buses, share their car rides, and use light rail. Well, light rail are those trains that you see occasionally, and they're called light rail because they're smaller and lighter, and they run on electricity. And you might wonder, how does that work? Let me tell you how we turn electricity into motion. One of the ways we do that is through a DC machine. DC stands for direct current. So what we have here is a diagram where here's a battery, here's a source of electricity. We're going to use that to send the current through this little coil that I've created. When the electricity goes through that coil, it's going to create a magnetic field that has negative on one side and positive on the other side. When that negative and positive interface with the magnetic field in the magnet is going to create rotation. So let me show you exactly how this works. I have two pieces of aluminum here. Aluminum is very conductive. I cut them from a can of soda, for that matter. This wire that I use to create the coil is very specialized, but you can find it at Radio Shack. So what I'm going to do is I'm going to put these pieces on this magnet, just like so. So they stay together, and I'm hoping they stay in one piece. The magnet is really strong, so we're going to put it together. Hope it stays together. Then I'm going to attach this other piece. So there it goes. And this is really light. I'm going to get another piece of tape here, and we're going to tape it. So that's what we have. We have basically this piece. Now I'm going to, the key piece, I'm going to put our coil through two little holes that I drilled, just like so. So what you notice is that the coil can rotate. That's the key element. We want the coil to be able to rotate. Now, I'm going to connect electricity, just like we have in the diagram. So I'm going to connect the positive side. I'm going to connect the negative side. And if I give it a little shove, it should stay together. There it goes. So that's the same principle behind a train using electricity to move. Pretty cool, huh? I have many experiments in store for you. I look forward to seeing you.